Hi everyone. Let us now continue with the part two of the topic database system architecture. So now let's go with database schema. So when you say schema, it is the collection of related objects in a database, meaning it is the collection of all the tables that you have created in one database. So we call it interchangeably with database or schema. Those two terms those two terms are two equivalent terms so that we can use it interchangeably. And within a schema, you have the interrelated objects. So one table is is related to another table. So when you say schema, it it is not referring to a person, but it is referring to a user which can manipulate the objects or the tables inside a schema. Okay. So when you say schema, you have three different models associated with it. First is the conceptual model, and it is also called the logical model. So in this model, the the basic definition or the basic structure of your database is being reflected, meaning what are the entities involved or included in your database, how these entities are related, and what are the constraints for these entities. Do we allow what do you call this one updating, or what are the other constraints that that can be involved in each tables, meaning how you are going to enforce foreign key primary key constraints. So this is part of the conceptual model. So and also in the conceptual model, you will be able to see the overall picture of how your database will work, meaning who are the users involved in that particular database, what are the access of each users. It can be that one group of tables or set of entities can be accessed by one user, or it can be accessed by two or more users. And then it is also in this conceptual schema which you will know the access levels of each users. So muna siyang overall blueprint. Kana makita bitaw nimo how exactly this example, how customer is related to address. So this is an example of a schema. I mean logical schema. This one is also another example of a logical schema. So given a staff, the staff can look after an item, and the item can either be a book or a DVD. And an item can be borrowed by a student. And the student, before borrowing, it can request for that particular item. So this is an example of a schema. You just have to recall your FDS as to how we build the ERD. That's your schema. Now let's go to the second component, which is the internal model. It is also known to be the physical model. So when you say the physical model, that is the actual implementation of your database in your database management system. So kanang gi-create ninyo na database in your PHP or in your MySQL workbench, that's the physical model. If you're going to generate the relational schema in PHP that schema is the physical model of your database. So that's the actual database tables that you are using in your organization, in which you can add, edit, delete data from it, right? So also in this database, in this physical model, you are makita mo dito where these tables, I mean, where these attributes are being stored in the tables. So this is an example of kato bitong physical na nga model or internal model, you will know that it's the physical model because you have there the you can see there the primary key and foreign key definitions. Then you can also see there the data types. Okay. So lastly is the external model or what we call the application interface. So this application interface or the external model is the part of the database schema in which users has interaction through a data input form or through an application software where you can add data, where you can edit data or delete data. That's the external model or application interface. So this is how this particular and by the way, also in the external model, it is usually where the end users interacts with your database. Okay, so this is an example of a database schema. You have here the end users or your application or external what do you call this? External model. So your external model will access your conceptual model. Kato bitong na kay table definitions, dire. And then when you do changes, the the changes will be saved into the internal level or to the physical level of your schema. All right. So let's go to the different architecture, database architecture. First is what we call the one-tier architecture. So when you say one-tier architecture, you have your server and in that server, naka-reside dira tanan ang files, ang database, ang application, and you have client computers, which accesses directly the server for the for it to access the database. So that's one tier. Okay. Then we also have two-tier architecture. So given a two-tier, you have your client tier and your database tier. So separate na sila, tanan. Okay? You have the three-tier. You have your client tier, your business logic tier, katong naa dito sa application server nimo, and your database tier. Okay, so apis sa application server, ay apis sa business logic tier, kana sa web services, kana mga web hosting, kanang mga API hosting na ana diri sa business logic tier. And then all the data is saved in a separate server, which is the database server. So for data independence, when you say data independence, that is ability to modify your schema or your schema definition at one level without affecting the entire schema at higher levels. So there are two kinds of data independence, the physical and logical data independence. So when you say physical data independence, it is the ability to modify the physical schema without causing application programs to be rewritten. So kung usabon nimo ang structure sa imong database in the physical level, dili na need it should not affect the application programs to be rewritten. Okay, so modifications at these levels are or at this level are usually to improve performance. So mo nang magbutang kag indexes, magbutang kag triggers, and so on and so forth. So that's physical data independence. So whatever changes you made in your database at the physical level, it should not cause your application programs to be rewritten. Now let's go to logical independence. So when you say logical independence, it is modifying the conceptual schema without causing the application programs to be rewritten. So meaning na kay idugang mga table, na baka idugang nga relationships, then it should not affect your what they call this one application programs to be rewritten. Okay. Now let's go to database development lifecycle. So it always starts in every, even in software development life cycle, it always starts with the planning. So we have here database planning. So when you say database planning, uh, it is here where you are going to define the domain or the scope of your database, meaning how big is your database? What are the features or functionalities included in your database? What are the constraints for your database? Who are the users of your database? How will you how will you provide storage? How will you store your database? So that's part of the planning. And then you also have here the the checklist as to what they call this one, to refer to when you do database planning. Number one is organization. So you are going to check your organization. What are the key positions or position or divisions or departments in your organization? Because it will matter, or this the the positions in the organization will matter and how you are going to develop your database. It is the basis for the different access levels of the users in your system. Okay, so number one is organization. So you have to know who are involved in that particular database system. And if you have listed now, if you already know who are these persons involved, what are their corresponding roles or access in the system? To what extent can they hmm, access the data in your database? And then you also have here function. As mentioned, you have to identify the functions that you are going to include in your system. What are the functions that you are going to include in your system? And with that functions, what are those processes and activities that will be included in your system? Then you also have here the critical success factors or CSFs. When you say CSF, this part of your system should be done correctly so that dili ma-jeopardize imong company. This part of your system will determine the success or the failure of your company. Okay, that's critical success factors. Next is data. So these, when you say data, what are the types of data that you are going to deal with in your system? What are the data to be included in your system? Okay, so apil na dito si customer data, na kay employees data, and everything else. Right? Next is system. So when you say system, it is the information and the organization's automated information system. That is, if currently na nabatay automated system and present the current automated system vis-a-vis with your proposed system, and then you cite the advantages of your proposed system over the present system. So that's part you cite or you enumerate the advantages of your proposed system over the existing system. And then for the uh, project, it's about the information about candidate projects that will be considered by the organization. So next is, after the planning, you have there the system definition. So when you say system definition, you have here to identify the scope, the different user groups, the application areas, the parameters involved in your system, and you are going on to do the discovery prototyping. So when you say requirements for or information needs or requirements analysis phase. Naka sa ikatulo. So you have this requirements discovery method. When you say requirements discovery method, you're going to investigate as to how the organization do such processes or how do they perform their daily transactions. So that is through an interview, through questionnaires, through collecting facts from existing documents, kung naa sila yung mga sa tawag na processing manuals, research and site visits, and discovery prototyping. So the goal for this requirement analysis is to determine what are the data requirements of the database in terms of primitive objects and to classify and describe the information about these objects. Then you also have to identify and classify the relationships among these objects, meaning how these objects are related to one another and what are the objects that has relationships, and to determine the types of transactions that will be executed on a database and the interactions between the data and the transactions. And lastly, to identify the rules governing the integrity of the data. When you say rules governing the integrity of the data, it refers to your business rules. So that's the goal of your requirement analysis. And after that, after you've done the planning, after you have done or you're done with the system definition, you're done with the information needs or requirement analysis, then that's the time that you will be designing your database. So given all all the information that you have gathered in your interview, in your requirement analysis, in your planning, then you are going to design now your database. So this is the process of creating a design of your database that will support the enterprise operations and objectives. So, muna na mag-create na ka og ERD. Okay? So, you are going to put into design the data that you have gathered in your interview, in your discovery prototyping, in your questionnaire. And then after that, after designing, you are going to develop a framework or to design a framework for your database design. So this will determine the information requirements. You have this will also analyze the real world objects that you are going to include in your database. Then in this part, you are going to identify what are the primary keys needed for each tables. Then you are going to further develop the business rules that will govern how one table can access or can be accessed and updated. And then you are going to identify the relationships between entities, and you have to plan your database security. And then next, after the framework, then you're going to do the implementation. So in the implementation, you have different steps or phases. Number one is uh, hardware or software acquisition. Mo nang naatay ginatawag nga hardware or software requirements. If the current hardware or software in the organization will not suffice the minimum requirement of the proposed system, then that's the time that you are going to acquire new hardware and software that can address the functionalities and features of the proposed system. And then once you're done with the identifying the different hardware or software acquisition, then that's the time that you can start programming your database. So muna tong i-convert na nimo ang logical model into physical model. Kato na mag-create na ka through your MySQL. Katong sa PHP may admin or workbench or sa pa ba? Postgre. Then after programming, na okay na rin kay testing. So na kay mga testing. So program testing, you have the sub systems testing and systems test. So daghan ka mga testing incorporate to check the functionality of your database that you have created. And then after the testing, then you will now go to training the users that will be using your system. So training na sa end user. Deployment na siya nga part. Okay? And after training of the users, then that's the actual deployment of the proposed system. So it can be muna siyang conversion nga part. So it can be parallel, meaning the proposed or the new system will run along with or simultaneously with the old system, or pilot, meaning paggamay-gamay lang sa ka og scope. So magsugod ka sa gamay nga sa isa ka office, padako, padako, padako. So that's for pilot testing or pilot conversion. Kumbaga magsugod ka sa isa ka department, and then if that department will be needing data from another department, then magkadako until nga makover nimo ang entire organization. Phased, most critical functions first. So mo na siyang pinaka mga critical functions ang imong unahon pag-deploy sa imuhang system. Then kay direct cut over. So this is when you say direct cut over, automatic mao siya imuhang gamiton katong bag-o nga imuhang nahimo. So that's for the different stages of implementation. And then maintenance. So in the this is the last part of the database development life cycle. So maintenance, because we all know that errors and bugs will appear or occur the moment nga ma-deploy na siya sa mga intended users. So when you say maintenance, that's the time that you are going to take note of the bugs and errors, then you are going to fix those bugs so that you can have a robust system. When you say robust, di siya, ay kanang kuan siya ba? Kumbaga, system that will give you correct output and that has less, if not no errors at all. So the methods needed for this phase is nakay audit. For phases, you have to audit. So example, for functionality sa order system, unsa to nga bug ang nahitabo, kano sa ni occur. So imo rin na siyang i-replicate. Unsa ni gibuhat kinsa nga user. Imo na siyang i-replicate. Kung ma-replicate nimo, then you need to fix those bugs. Kabalo i-trace na yun nimo asa nimo or unsa nga table ang involved, unsa nga transaction ang involved para ma-fix nimo siya. And also you have here how to avoid risk. That is, watch changing business requirements and set priorities. All right, so that's all for database architecture, database system architecture. So this is the end of this topic, and we'll have another set of assessment.